Welcome to Improper Integration with Infinite Range. So the general idea here is if we want to integrate a function with a vertical asymptote, so if our integrand has a vertical asymptote, then the fundamental theorem of calculus doesn't apply. So what we do is we split the integral at the asymptote. And then we let the bounds approach the asymptote. So essentially, if I were to draw a quick picture, if we have a graph that looks like this, and we want to find the definite integral, so that's like a, I don't know, 1 over x minus 1 graph, say, or 1 over x minus 1 squared graph. If we want to take the definite integral a little to each side of that vertical asymptote, what we can do is we can break at the asymptote. And then we will take bounds just to the side of the asymptote, find those slightly smaller definite integrals, and then let the bounds approach the vertical asymptote. I apologize, that picture got kind of busy. I will draw it again when we look at the actual formula or definition. So when we want to evaluate an improper integral, I realized I'm missing an E there. That may or may pop up. All right, when we want to evaluate our improper integral, let me update my screen. So if f has a vertical asymptote at x equals c, and c is somewhere between a and b, then we have the definite integral from a to b of f of x dx should be really split as an integral from a to c of f of x dx plus an integral from c to b of f of x dx. And then we have essentially where the integral from a to c of f of x dx is defined as the limit as t approaches c from the left side of the definite interval from a to t of f of x dx, and the definite integral from c to b of f of x dx is the limit as t approaches c from the positive side of the definite integral from t to b of f of x dx. So again, drawing this picture, we have our vertical asymptote at C. We have our A and B off to the sides. Whatever our graph looks like in between, we do have our vertical asymptote at x equals t. Sorry, at x equals c. Essentially what we're doing is we're picking some t to the left of c, and then looking at the definite integral from a to that t. And then we are letting t approach c from the left. So we're getting closer and closer to the entire left-hand side of that definite integral. Similarly, we pick some t on the right, and we take that definite integral from t to b. And then again, we just push that bound closer and closer to c coming from the right. And eventually it should give us our improper integral from a to b once we put it all together. So in the next video, we will go ahead and look at some examples.